Okay, so far in this unit we've solved several different types of equations, but in all of those types of equations the variables were all on the same side of the equal sign. So when we draw our line through the equal sign, all of the variables were either on the left or all of the variables were on the right. In this new type of equation that we're going to be learning in this lesson, we're going to have variables on both sides of the equal sign. As you can read at the top of this slide, we must get the variables together before we start solving. So again, as always, the first thing that we do is we draw the line, and we're going to work first on this equation, and you'll notice that we have the exact same equation over here, and we'll get to that in a second. There is a second method, a second way that we can always approach solving these types of equations. So we draw the line, and then you'll notice that we have a 5w on this side and we have a 2w on this side. The first thing you have to do is decide which one you want to move. So I'm going to move the 2w, and the way that we do that is we add the opposite. Now recall, if we add the opposite on the right, we also have to add the opposite on the left. So these two w's cancel out. On this side, on the right side, we have 13, so I'll bring that down. On the left side, we have 5w plus negative 2w. So I'm going to combine those like terms, and that gives me 3w, and then I bring down the plus 1. Now you'll notice when I wrote the negative 2w over here on the left, I put it underneath the 5w, because it wouldn't make any sense to put it underneath the 1, since 1 and negative 2w are not like terms. I want to put it underneath the term that I'm actually going to combine it with. Okay, so we've canceled out the 2w from the right, and we've moved it over to the left. Now I have an equation with the variables on only one side. In this case, my variables are on the left. So I'm going to continue this process. The rest of this process is simply solving a two-step equation. So I add the opposite of positive 1, so I do negative 1 on both sides. I bring down 3w. 13 plus negative 1 gives me 12. And my final step to cancel out the 3 times w, so I'm going to do divided by 3 on both sides. These 3's cancel out. That gives me my w alone, and 12 divided by 3 equals 4. So 4 is my solution. In this equation on the left, this one that we just did, I chose to cancel out the 2w. If you chose instead to cancel out the 5w, and that's why we have the same equation copied over here on this side, if you chose to cancel out the 5w instead, what you'll see is that our solution at the end is going to be exactly the same. The work along the way is going to look a little bit different because our w is going to end up over on the right-hand side, but the solution at the end will be equal. It will be the same solution that we got the first time. Okay, so I'm going to do this one a little more quickly since we kind of already saw the process a little bit. So I'm going to be canceling out this time the 5w. So the opposite of 5w is negative 5w. Those cancel out. I have 1. I copy it down. 2w plus negative 5w is negative 3w. And I copy down plus 13. Now my w is on the right. So always, if the variable is on the right, that's where it will end up in our answer. And so the rest of my work is because I need to get the w alone. So I need to add the opposite of 13, negative 13. These cancel out. 1 plus negative 13 is negative 12. When I combine those, I get negative 12. Bring down the equals, and I bring down negative 3w. That's negative 3w times, times w. So divided by negative 3. Divided by negative 3. Those cancel out. I have w alone. And negative 12 divided by negative 3 again gives me 4. So the work looks a little bit different because the variable is on a different side in these two different methods, And you'll notice that we have some negative values over here on the right that were positive when we did the process over here on the left. It doesn't matter which variable term you choose to cancel out in the beginning. Your solution will always, always, always be the same as long as you don't make any errors in your process. Okay, let's try one more example. So I'm going to draw the line. And my choice, the first thing I have to do is choose, am I going to cancel out the negative 7p or am I going to cancel out the negative 3p? I'm going to choose the negative 3p, but if someone else chose to cancel out the negative 7, it does not matter. You will get the same solution. Okay, so the opposite of negative 3p is positive 3p. So I'm going to do that on both sides. These cancel out. I bring down the 46. I bring down the equal sign. I bring down the 10. And now you'll notice I wrote the plus 3p underneath that negative 7p because those are the like terms. Those are the terms that I'm going to combine. So negative 7p plus 3p is negative 4p. And now I have all of the p's over here on the left-hand side, so I know in my solution, p is going to be over on the left. Now I have a two-step equation, so I'm going to add the opposite. So plus negative 10 on both sides. Those cancel out. I bring down the negative 4p. Now I have 46 plus negative 10 gives me 36. And my final step is to cancel out the negative 4. That's negative 4 times p. So to cancel out a value that's being multiplied with our variable, we have to divide. Those cancel out, we get our p alone, and 36 divided by negative 4 gives us negative 9. So p equals negative 9 is our solution. Again, I chose in the very beginning, in the first step, to cancel out this negative 3p. If someone else chose to cancel out the negative 7p, their solution at the end would be exactly the same as mine. The work would look different, but the solution would still be p equals negative 9. Okay, so to summarize what we just learned in this lesson, to solve an equation that has variables on both sides of the equal sign, the first thing that we do is exactly what we do always. The first step is to draw the line. That helps us keep things organized, and especially in this case, it helps us to identify what variable is on the left and what variable is on the right. So after we draw the line, number 2, we have to choose which variable term you want to move. And the way that we move it, the way that we get it to cancel out on one side and move to the other side, is to add the opposite. After you add the opposite of that variable term, you simplify, so you actually combine the like terms, and you bring everything else down. Now you should have a two-step equation that has only one variable term. The next thing and the final thing that you have to do is go through what we know about solving two-step equations. And when you get to the end of that process, you'll have the variable alone on one side, you'll have a number on the other side, and we're done. That gives us our solution.